Welcome to Lesson 19, more writing, evaluating, and finding equivalent expressions with rational numbers. Now this first activity is a classwork activity, and it's called Tic-Tac-Toe Review. And the idea here is to see how well you would be able to recognize equivalent expressions, okay? So in class, of course, you would be able to choose any of these expressions on the left and place them in any of the 9 tic-tac-toe boxes. Okay, but for our purposes here, to make this a little bit easier, a little bit more manageable, I'm going to go ahead and show you where to put each of these expressions on the left into which box, and we'll all do it the same. And then what I'm going to do, I'm going to go ahead and present you with other expressions which are going to be equivalent to one or more of the expressions that you have on your tic-tac-toe board. So it'll become more clear as we go. But first thing we should do is go ahead and fill in our tic-tac-toe board. Okay, so I've gone ahead and filled these in, filled my tic-tac-toe boxes in like this. So if you would go ahead and just pause the video and do the same, just transfer these expressions over to your tic-tac-toe sheet. And after you've done that, come on back and we'll begin. Now, of course, at the end of this game, we are all going to have the same answers, so we will all get tic-tac-toe at once, which should be fun. Yeah. Anyway, here is our first expression. This is from my teacher list, and that is right here. It's in red up top. Okay. So now what you need to do is you need to match that expression to the equivalent expression or expressions that exist in the tic-tac-toe board. Now in class, you can imagine how much fun this would be. I could put this up on the screen in front of the class and you guys would have to work it out. But let's go ahead, and I'm going to go ahead and work that out with you right now. But in the future, right here in the future, like as in throughout this game, what I will do is just go ahead and post I'll just show you the answer. But what I want you to do right now, though, is I want you to go ahead and pause the video and go ahead and see if you could actually figure this out. Which one of these 9 expressions on the tic-tac-toe board, the purple expressions on the tic-tac-toe board, are equivalent to this red expression I have at the top of the page? So go ahead and give it a whirl, and when you come back, I'll show you how to go about figuring this out. Okay, so here's the expression we have to work with, and that's this 2x plus 2 parentheses x minus 6. Okay, so you know, if you've taken in much of what we've talked about thus far, you might know one of the first things you might want to do is to go ahead and, using again the order of operations, go ahead and figure out this this parenthetical right here. Okay, and what we know about this parenthetical is that we can actually distribute this out. Okay, so let's keep this 2x, of course, because we can't do much else with that, plus, and now let's go ahead and here and distribute these 2's here. So 2x minus 2 times 6 is 12. Okay, so what I've done is I've just applied the distributed property to this parentheses here, okay, and distributed that out. Now it might become clear to you here. One thing that you're going to learn in the coming years of algebra is this idea of combining like terms. Okay, so combining like terms, all right, or like expressions. All right, so you can see these two are alike. Okay, because they have a coefficient and then they are followed by an x. All right, so if I take a 2x and I add another 2x, I have 4x. Okay, and my 12 is going to stay the same because I have nothing to combine it with. So that's as simple as it gets. Now, if I go back to my tic-tac-toe board, I will see 4x minus 12 right there. Okay, so go ahead and put in an x through that 4x minus 12 because that is equivalent to 2x plus 2x minus 6. Okay? All right, so I'm going to go ahead and put my next equivalent expression up the top. I want you to go ahead and do the lion's share of this work on your own. Hopefully you guys are getting it. Here's my next one, is 4x minus 16. Okay, now this one, you might see is maybe a little bit more simply written. Okay, it's down to two different terms. You have an x term and then you have a whole number term. All right, so you might want to work just the opposite, just the opposite way that we worked the last one. Okay, so go ahead, I'm going to pause again, and well, I want you to pause, okay, and I am going to actually pause, and then turn this back on, and I'll go over the correct answer with you. Okay, so if you you went ahead and did that, and if you actually noticed something, if you actually looked at the last problem, you notice that this new problem looks a lot like this. Okay, it looks a lot like this. So if you maybe made your way back, you could find something that maybe looks somewhat like this. But let's go ahead and see. All right, and which one did you choose? If you chose this one, you were correct. Okay, you were correct. Because what I can do is I could just take out that 4 from here, because remember we talked about, we look at a common denominator, not a common denominator, but a common multiple, or sorry, common multiple, or common factor, common factor. So we could take 4, and then inside of the parentheses, we could put x minus 4, because what I'm going to do, what I can do eventually is then go ahead and distribute this out and do 4 times x, which is 4x, and then 4 times 4, which is 16. So 4x minus 16, which is the same as that. So these are equivalent. This one here and this one down here. Okay, so now we have two x's right there on our board. Okay, so here we go. Hopefully this is getting more and more comfortable for you. I sure do hope so. Let's go ahead. I'll give you the third teacher list expression to match. It's going to be 1, and you can imagine that the 1 outside a parentheses is pretty useless. So, but it's there anyway, just to see if you can work with it. Okay. Okay, there we go. So we have 1 parentheses x plus 2 plus 2 parentheses x minus 2. Okay, so go ahead and work that one out. I'm going to go ahead and pause. Maybe you're seeing something already. Okay, so maybe you saw the answer, got the answer right away, and I talked about that 1 in front of the x plus 2 being meaningless, but it is kind of, because what I'm going to do, if I distribute the 1 with the x plus 2, it's just going to be x plus 2 plus, and now I can distribute my 2, so that's going to be 2x minus 4. Okay, so now I have all of this. I have x plus 2 plus 2x minus 4, and what I do, like we had talked about before, is combining like terms. I'm going to combine all my x's, and I have an x here, and I have a 2x here. That means I have 3x. Okay, and then I have a positive 2 and a negative 2. Negative 4, which means I have a sum of negative 2. So then I have 3x minus 2. 3x minus 2. Okay, now I have 3x minus 2. Does that match any of those on the board? That is a question. Some of you may want to put a strike through this one, but we can't do that. And if someone could maybe figure out why, because if we do take a look at this, if we look at 3x minus 2, and what you notice is different here is that what you don't see here is you don't see any parentheses. Now these parentheses, in this case, you can see what a difference they make, because these parentheses, now if I went ahead and distributed this out, 3 times x is 3x, that stays the same. But then 3 times negative 2 is negative 6. So that's going to be 3x minus 6. Okay, 3x minus 6. That's what this one is equivalent to. This one down in that lower left-hand corner of the bingo board, okay, or tic-tac-toe board. Bingo, tic-tac-toe, or bingo, I guess, right? Anyway, yeah. So this is actually it's not equivalent at all. Okay, it's not equivalent to any of these, unless you guys can find another one up here that's equivalent to. We can look around here. Anything equals 3x. X minus 2 plus 2x. I'm looking at this one right here. This one. But I have an x and then another x, an x and then 2x, and that's 3x. But now I have a negative 2 and a negative 4. That's negative 6. So that's not going to be. Ooh, but we have an idea where that one's going to be later. I don't see another. Okay, so we're just going to take. Well, I'm sorry if I'm repeating myself here, but I suddenly noticed that my recording mode had quit on me, and I'm not sure if I had even started this problem yet. But anyway, what we're looking at now is we're working with this expression, trying to find an equivalent down on our board. Okay, and what happens with this one is that, of course, we have one outside the parentheses. It makes no difference to what's in the parentheses. So I just did that, and now I'm going to distribute this 2 times x is 2x, 2 times negative 2, okay, is negative 4. All right. Now if I combine like terms, which is what I do next, and again, becoming familiar with that like term idea, I have an x and then 2x, which gives me 3x, and then I have a positive 2. This is where a positive and negatives mean so much, and then a negative 4, which is going to give me a result of negative 2. So what I end up with is this expression down here, 3x minus 2, which is equivalent to this one that we started with. But our task now, though, is to see which of it, does this exist on the board? And some of us may be inclined to say that this one is equivalent, or this one is the same as this, when it actually is not. Okay, and let's talk about that. These parentheses, location of parentheses is so vitally important, and you can see it right here illustrated in this example. Because if I went ahead and distributed this problem out, 3 times x is going to give me 3x, but then 3 times negative 2 is going to give me negative 6. So, in fact, this one here, this expression here, is actually equivalent to 3x minus 6. Okay, so in fact, and I've looked at the rest of the board, this does not exist anywhere on the board. Okay, so just take all that out. We do not have, in fact, an equivalent expression for this one here. So let's go ahead and erase that, and let me throw up the next one. Okay, hopefully some of you guys and gals discovered that yourself. Okay, here's another one: 4 parentheses 3 minus x. So go ahead and find that one, and then come on back. Okay, so yeah, taking this one and distributing it, you would see that 4 times 3 is 12. 4 times negative x is minus 4x. And right away, revealing that this expression here is equivalent to the 4 parentheses 3 minus x, which we started with here. Okay, but hopefully you could take a look, and I'd like you to look a little bit more closely. I'm not sure if anybody found another one on the board, but there is actually another one on the board that is equivalent to this one, and it's equivalent to that 12 minus 4x. So if you look for something where you see 12, and you can see 12 here, and then if you combine these two like terms right here, and again, combining like terms, always very important. It's probably the most important thing you do is when you solve for this one up here, make sure all your terms, your like terms are combined. Okay, so in this case, you're 12, because 12 is your only whole number, and then you have a negative 6x, and then a positive 2x, which is going to give you a negative 4x. Okay, as your total there, and you can see that that is also equivalent to the one we started with. Okay, so let me back off all those strokes. But yeah, this one is actually going to be the same, so it's going to be the same as this one there. So this is also equivalent to this one here. So now we have our board, our tic-tac-toe board looks like this. No tic-tac-toe yet, but looks like we're getting close. Not exactly sure if we're ever going to get tic-tac-toe because, oops, I just erased a lot of stuff I didn't want to erase. Let me go back and put these two back in. Okay. Alrighty, so here we go. Here's our next. Our next one is 4, and then parentheses 2x plus 1 minus 12x. Okay, see if you can play with that one a little while and find an answer, find an equivalent expression. Remember, in the very end, combine all like terms. Everywhere you are, combine all the like terms that you find out eventually here, as well as on the tic-tac-toe board. Okay. Okay, welcome back. Let's go ahead and solve this together. And I'm going to first use my distributive here. 4 times 2x is 8x. 4 times 1, positive 1, is 4 plus 4. And then minus 12x. And again, remembering that we need to then combine like terms. We have 2x terms here, so we have negative 12x. Remember, you've got to include that negative. And then a positive 8x, which is a negative 4x. And then we keep our plus 4 because there is nothing else to combine that with. This is what we end up with right here. And you'll notice right away that, oopsie doozy, we have tic-tac-toe. Tic-tac-toe. Anyway, yeah, so if you see, okay, so that's one of those. I don't know, we can look on the board, though, and see if we can find another that might be equivalent to that as well. And I will tell you right now, there is one that is equivalent, another that is equivalent to it. And hopefully you may find it. Look at one that looks like it might be vaguely similar. All right, and I'll cut to the chase and show you that one. And that one would be right here, because if you see you have 8x, and we're combining like terms, then you have a negative 12x, because that looks a heck of a lot like this step right here, doesn't it? And if you notice that step right there is actually this one here, and that's going to be negative 4x, and then plus 4, okay? So this actually was the second step. So here we go, we have another tic-tac-toe. And I'd like you to just complete this with me. Let's just complete the rest of the board and find equivalents. And I think that might be it, because up here I'm seeing only 3 x's here. Down here I have 4. I have 4x if I multiply 8 times a half x, but this needs to be a negative x right here to be equivalent to this one we're working with. So, okay, we're done there. Let's go ahead and erase all that. So we have 2 tic-tac-toes. We don't care about tic-tac-toe anymore, but you can see how much fun this would be in class. Okay, it does take some time, though. Okay, so let's go ahead and give you my last one. I have a last expression, and it is 3x minus 6. So go ahead and find any and all that are equivalent to that 3x minus 6. Okay, you may remember from before, okay, that one that was that worked out, one on the board that actually worked out to 3x minus 6, and that was this one down here when we distributed this out, 3x negative 6 minus 6. So this one was equivalent, and there was actually one more, and that one was here. If you're going to take this one here and actually combine like terms, you see we have 2x there, we have 1x here, so that's 3x. We have a negative 2 here, and then a negative 4 here. Combine those, and that gives us a negative 6, which is 3x minus 6, which is the same as that. Boom, bitty boom. Another one, so we have 1, 2, 3. We have lots of tic-tac-toes. Now this one, if we work it out here, the last, our sole surviving one, we have, that would be 8, so 8 times 1/2 x is 4x, and then 8 times negative 2 is negative 16. So that's what that one is. It's not equal to that one, or not equivalent to that one. But was it equivalent to one that we did already? And I am noticing that it is actually. This is actually equivalent to this here, because we can actually put, we could actually make it look exactly like that. So I missed that one. I wonder if you guys did, or maybe you got it. See, this is the same. Because this could actually be 4, and then x minus 4. This one here works out be the same as